example about bond futures. Okay, in the bond futures, is interest rate and then what is the relationship between interest rate and bond price? Is it positive correlated with negative correlated? Yeah, it is negative correlated. So therefore, in bond futures, if we compare bond futures and bond forward, which one should be higher? Eh? Yes, exactly. Isn't it not difficult, right? It's too easy. But anyway, that's the idea. This is what is going on here. Yes, Dave? No, if interest rate is deterministic, if interest rate is deterministic, correlation is zero. Right? Correlation is zero, so futures and forward contracts should be same. Okay. When something is deterministic, we cannot calculate correlation. We can calculate correlation and everything else only when they are stochastic in future. If they are like deterministic and constant, then it is zero. So when deterministic, they are futures and forward contracts are the same. Similarly, when they are independent of each other, then even if there is interest rate risk, but if that risk is independent of underlying asset, then again futures and forward contracts should be same because there is zero correlation. Yes, Kevin? Deterministic means you know what is going to happen in the future. Deterministic future. Any other question? Like I don't know, like a stock cost 200 future. Of course, interest rate and the stock market are sometimes correlated, but the correlation is kind of weak, actually weak. Therefore, in case of this bond contract is strong, but when underlying asset is like KOSPI 200 or like Nikkei 200, something like that, then the futures contract and forward contract should be very similar to each other. I think that's my guess because the correlation is very weak. Any other question? Okay, and then let's go to our example on the binomial tree. Okay, the fun one, the fun binomial tree. The most exciting part in this class, I think, Google spreadsheet. So again, this is data maturity 6 months, 1 year, 1.5 years, and value of contract that pays this year, like this. And from this one, we can calculate yield, and from yield, we can calculate forward rate like this. This part we did it before. And delta is 6 months because time step is all 6 months, so 0.5. So let's assume that face value or 100. Okay, 100. What is Kevin's method? Let's delete it. You don't need it anymore. So this is interest rate model. It is given from God. Let's assume that for the timing, interest model. And then given this interest model, okay, so this is 6 months interest rate. So this is what we know. This is same to this one. Okay, but then future interest 6 months rate can go up or go down. It doesn't know what is going to happen. Okay. And then when we have this interest rate model, then because it is about 6 months rate dynamics, then we can keep track of 1 year bond. 1 year bond. Currently, the price of 1 year bond is what? How much? This one. Price of 1 year bond is this one. And then next period, which is 6 months later, and then it becomes a 6 months bond now. And then 6 months rate is this one and this one. And from this one and this one, we can calculate bond price like this. when interest rate is one, bond price this one. When interest rate becomes bond price this one, right? So it is 1 year bond, 6 months later it becomes 6 months bond because we have 6 months to go. And at terminal period, because we are assuming there is no risk, there is 100 for sure, right? So it is bond price. Any question? Yeah. So our question is, we are let's assume you are interested in the derivative price. Derivative price, in this case, is the interest rate derivative. So, yes. In general, let's assume that we are interested in the derivative that pays some money when interest rate go up and some money when interest rate go down. In this case, swap rate is 2% and notional value is 1 million. So swap rate, so when swap rate is 2%, so when interest rate is 3.39%, then this one minus 2% multiplied by 1 million, so I receive this one. But when interest rate is go down, now I can receive only this one, but I have to pay 2%, so notional value is million, I'm receiving this one. So this is one kind of example, swap contract, and we are interested in the value of this contract. So let's generalize this one, okay? Let's generalize this one. Actually, I explained it already, but let me explain again. So where I write it down, okay? Okay. Scenario. There are two scenarios, right? 6 months later, scenario in 6 months. In 6 months later, we have two possibilities. Interest go up, interest down. Interest up or interest down, right? We have two scenarios. And then in two scenarios, we have three assets, but let's think about only two assets. Okay, short-term bond and long-term bond. 6 months later, short-term bond is 6 months bond. Let's be specific. 6 months bond means maturing in 6 months, and long-term bonds 1 year bond. 1 year bond. Okay. This is very important part, so please keep focus. So 6 months later, what would be the price of a 6 months bond? Yeah, so what is that? 100. Exactly, 100. Okay. So par value, which is, I think it is face. Okay, so this is face. And then for 1 year bond, what is the price of a 1 year bond in 6 months later? Which is, when interest rate is up, it is this one. When interest rate is down, this is this one. Right? Right? And then derivative price. Derivative price is, okay, derivative price, let's assume, okay, for swap, when interest rate is up, I receive this one. When interest rate is go down, I receive this one. And the price, now price, what is the price of a 6 months bond? What is the price of a 6 months bond? The price of a 6 months bond is given, right? This is this one, right? And what is the price of a 1 year bond? It is also given, which is this one, right? But then price of this contract is something we don't know, right? We don't know this one. So our goal is to compute this one, right? And then I explained last class that we basically, our idea is, that we replicate this cash flow with by combining this one and this one. So it's like my favorite pizza example. We are interested in the price of pizza. It's a pizza. And then this is the price for dough and the price of topping, right? If we know the price of dough and price of topping, and if we know recipe of the pizza, then we know how much topping we have to buy and how much dough we have to buy, and we combine it becomes pizza price, right? That is our approach. Okay. Then let's think everything in terms of return. Okay. Okay. And then 6 months bond return and 1 year bond return. Okay, let's think about it. Okay, very good idea. If you are sleepy, please go there. Actually, it is actually good for your health, right? Good for your health. I mean, sitting on the chair and just taking a lecture is actually not good for your physiology, actually. So I heard that. So it is actually good for your health to stand up and taking lectures. So I don't mind you standing up taking lectures. So anyway, so let's think of everything things in terms of return. Then 6 months return is for the next 6 months. The return is when interest is really high. The return is this one divided by this one, right? Yes. And then this return is this one. This is 1, likewise, right? So if we think everything in terms of return, if we invest $1 in 6 months bond, I have this one, this return in up scenario, and this one in down scenario. If I invest, so they are same, right? It should be same because it is risk-free rate for the next 6 months, and it is given, so it is constant. But 1 year bond, if interest rate is up, then my return from bond is lower, right? Because bond price go down, so interest rate is go up, then my bond return becomes lower, okay? And if interest rate go down, my next period bond price up, so my bond return is higher. Okay, so this is return. And next, let's think about it, okay? We invest X dollar over here. We invest Y dollar over here. Then portfolio performance. My portfolio performance, portfolio return, okay? Portfolio performance is that if I X dollar here and if it is in good scenario, then what is the, how much money I make? It is basically because I invest X dollar and interest rate goes up, so basically I make, let's say, round this one, 2, and then right? Yes. Okay. 2. Okay, and then 3. So when I invest X dollar in short-term bond, when interest rate go up, then my return, since per dollar I make $1.009 6 months later. Then if I invest X dollar, so it is 1.009 plus X, right? That would be my return. Okay, same. Yeah. But then if I invest Y dollar, then it becomes round. Since I also invested Y dollar, this is what? Now my performance is something like this, right? Any question until now? Right? I invest X dollar over here, Y dollar over here. So my performance when interest rate is up is like this. Likewise, when interest rate go down, my performance is simply this one, right? Right? And then we are almost done. So by investing X dollars in Y dollars, we know what's going to happen in my portfolio in up scenario and down scenario. And our idea is that by matching this one into this one and this one and this one, okay, we can perfectly replicate this derivative with the short-term and long-term mode, right? That's what I mean by replicating pizza with this one and this one, right? So we know how much we can buy this topping and how much we can buy for this dough. And then it is easy to compute. It is a two equation and two unknown, right? Equation number 1, equation number 2. Okay, so this one should equal to, in the end, should equal. Yeah, okay, let me skip this one. Okay, two equation, two unknown. So basically, you can solve this one, right? Any question, right? I mean, now middle school students can solve for X and Y. So let me calculate what is X and Y. X and Y is, if we think everything in terms of matrix algebra, then we can regard this one matrix, and by multiply this matrix, multiply X, Y, then it becomes equal. So if I multiply inverse matrix of this one with this one, we can get X and Y, right? So let's calculate inverse matrix of this one. Of course, I mean, I'm using linear algebra because it is cleaner, but you can solve systems of equation by hand. That is another way. So let's calculate inverse matrix. M inverse. And then I calculate inverse matrix of this one. Okay, so this is inverse matrix. So, okay. So basically, what we are solving for this one. So what I'm doing is that this one multiplied by X, Y is the cash flow, right? Cash flow 1 and cash flow 2 from derivative. So this X, Y is inverse of this one and then this one, right? And then I can multiply this one and this one. So X and Y is I can multiply this one, and then actually I have to, okay. So M multiply this one, and then relative price. Okay. So actually this is big number, pretty big number. So it means that if I invest this amount in X, and if I invest, well, how much is that? It's a pretty large number. So format, number, and then where is the more format, custom number format. Okay, well, I don't, anyway, here. So, okay, it means that if I invest about 1,000,009 something in X, and Y is negative. If we borrow this amount, then I can perfectly replicate this one. Then what should be the price of this derivative? Since I can replicate this cash flow from derivative by investigating this one and borrowing this one, so the price of the derivative price, X plus Y, is sum is this one. So actually this one should be derivative of price. Okay? Yes, so this is the same to this one. So we got this derivative price. So any question about this? So again, our idea is simple. By investing in $X in short-term bond or $Y in long-term bond, we exactly replicate exactly the same cash flow derivative. So the sum of this X and Y should be that derivative price. Is it clear, Dave? Okay, right? Yeah. What function? I didn't use any.
Red colored one and red colored letters.
Yeah.
You use bold. This is bold block.
Oh yeah, you can do matrix algebra with Excel. You can please Google how to do matrix algebra in Excel, and you can find it. This is very useful technique. Yes.
What is this inverse matrix actually? Why is it good for matrix?
Why do we need inverse matrix?
What is it showing?
I mean, okay. This is the intermediate step, right? So in order that this one should be equal to this one and this one should be equal to this one, and in order to solve it, I will have to get inverse matrix of this one and inverse matrix of this one, and I multiply this one, and I got X and Y. And in order to do that, it is intermediate step. Yeah. It is the inverse matrix, this one. So we ought to calculate this, I need this one. So again, yeah. So about this part, okay, so let's be step by step. So basically, we want to solve this one, right? Our goal is this one should be equal to this one, right? And then if we express this one in matrix, it is the express this one in matrix. This is the and then Y. And this should be equal to this one. This should be equal to this part. Right? This one should be equal to this one. Right? This one should be equal to this one, right? And then in order to solve X, I have to get the inverse matrix of this one, and this is the inversion of this one is this one. Inverse matrix. And by multiplying inverse matrix and then this one, multiplying this one and this one, so we are moving this one over here, right? Then we can get X and Y. So that's why I need the inverse matrix over here. Is it okay?
So you need to solve for X and Y.
Yes. So basically, because matrix algebra is neat, that's why I'm using matrix algebra. But you don't have to use matrix algebra. You can just solve one by one as you learn in middle school. Here's two. Eh? Yes, simultaneous equation. But again, matrix algebra is actually neater. If you can do matrix algebra, please do matrix algebra because it's neater and less prone to mistake. Yes, so this is the idea. So the derivative price should be this one. And then return from derivative. Derivative return is this one. Well, actually, I can derivative return is this one. Divide by derivative return is now more volatile, right? It is a plus when up scenario and minus 2%, minus 2 in down scenario, more volatile. And actually we can, there is a lot of interesting thing going on. So this is very important part. Any question until now? Any question? No, no question, right? And then this is very, there is not many interesting thing going on over here. First, right? We invest, right? We invest in short-term bond. We invest in X, right? But then, okay, let's make derivatives more simple. Let's make derivatives such that bond option, okay, bond option. So let's make it bond call option. So bond strike price is this one. So let's change the derivative price. Now this one. So now derivative changes like this one. So to make matters simple, let's think about bond put option. In case of put option, when bond price go up, then I don't make money. When bond price go down, I can make money because it is right to sell. So let's think about the bond put option. Okay. In case of bond put option, okay. In case of bond put option, then again, I invest in short-term bond, and basically the recipe, okay, recipe for this derivative is again it is like a dough and topping, and in this case, actually it is not because I'm short position, so it is not good analysis anymore. But in this recipe, I invest in short-term bond and I short sell long-term bond. Because it is negative and it is positive, right? And then this one makes sense, right? This one makes sense. I invest in short-term bond and short sell long-term bond. It makes sense because in this bond contract, in the bond derivative, bond put option, I make money when only bond price go down, right? And then usually when asset price go down, we can make money when asset price go down only if we take short position, right? So basically in the bond put option is like we make money when bond prices go down. Therefore, it should include short position on that asset, right? So it makes sense. That's why we take short position on this long-term bond. Because it is written, this bond put option is written on this long-term bond, and we can make money only when interest rate go down, go up, where bond price go down. Therefore, we have to take short position. But so one idea, this part is obvious, right? That's why we take short position on long-term bond. And in addition, now we have to match. So we have to match these two sides. I take appropriate the other position for short-term bond in order to match the size of the derivative and then portfolio. Okay. Match exact dollar amount. So through the short position in long-term bond, basically we are matching the slope when bond price change. I have to. It is amount. Like there is a change in put option payoff when interest rate is up and down, and there is a change of price when interest go up and down in long-term bond. So there is slope, which means change in bond put option payoff and change in long option payoff. And in order to match the slope, change of the size in each side, we have to take this amount of long-term bond. Then we can match the slope. Then after we matching the slope, then we have to match exact location. If we think everything in terms of geometry, in order to match the location, we use short-term bond. So we match the location and match the slope, so we can match bond put option payoff and then portfolio payoff. So that's the basically idea. That's what is going on here. Any question? No? Okay, and then let's write this down in terms of mathematics, more mathematics. So, okay, let's write down this one is the, let's write this one as the, okay. So okay, so let's writing down everything in equation. So in case of bond derivative payoff, let's say derivative payoff is du and dd. Okay, so this is derivative payoff when interest rate is up, interest rate is down. Okay, and then we are basically solving for x and y. And then this one is a short-term rate. So basically this is given R. And bond return, this is RU. Or let's call this is RU and this is RD. So RU is the return from long-term bond when interest go up. So actually it is negative. It actually is low and this is, should be high. So actually we are solving for this. So x plus y is this inverse matrix of R, U, RD, inverse of x and inverse of du, dd, right? And then derivative price is x plus y. So this is the derivative price, d0. Derivative price is 1, and then inverse matrix, this one, and du, dd, right? And then actually, let's compute this one. Okay, let's compute. It is we can calculate inverse matrix of this one, right? The inverse matrix of this one is, let's say, we have there should be determinant. So R determinant is this one multiplication of this one and minus multiplication of this one, right? So it is R D minus RU. And then matrix algebra, so we change the location of these two. RD R, and we put minus RU, and then R, something like this, and then DU, DD, right? Now it is the high school math. So actually now we can calculate this one multiplied with this one, and this one multiplied with this one. So the 1, and then R, RD minus RU. And then if we do it, then it is the RT DU minus RU DD. And this is RTU minus RTD. And then since we multiply 1, so let's delete this one, and we have to plus this one, right? So because we multiply 1, so yeah. Right? And then, well, if you take a look at this one carefully, then it's a bit interesting. So I'm running out of space. How can I mean, can you read this one? 박영주 학생, 이거 읽을 수 있나? 보이나? 안 보이나? Okay, right. Okay. Then let's compute this one. Then the sum of this one, so it is R1 over R RT. No. I think I have a better idea. Okay. copy, paste. Cool, yeah. And then sum of this one, so we can put this one together, and we can put this one together, right? Same du and dd thing, and then wait. Actually, there should be minus over here, right? Minus, right. Yeah, this is plus minus, right? You know, when I take inverse matrix, then I can change the location here minus this one, right? So there should be minus. So yeah, sorry, and now everything's okay. UD, right? So no. Actually, sorry, I already multiplied this, so I don't need this part. So we can plug du thing together and dd thing together, and then it is big parentheses and rt minus r du plus, well, this is the r minus r u d d, right? It looks like this one, right? And then I can simplify this one further, like 1 over r, and then let's say this is the this is d, so let's say this is the 1 minus p du plus p, let's define p dd. Here p means rt minus ru r minus ru. So this is p, this one divided. So p and this one is rd, so it's 1 minus p. Right? Everything clear? Right? And then this is the actually p is looks like a probability. It looks like probability, isn't it? So if you do some imagination, this p looks like probability. So well, we can change this one 1 over r e some q. Let's put q. This is not real probability. It is just this one from this one. So t future derivative cash flow. Okay. So in the end, we have. I think I wanna save this one. Derivative replication. Okay, I save it, and then I can upload this one, new file upload. Where did I save it? Replication. This one. Replication. Okay, replicate it. Okay, so then share. How can I share? Share. Okay. I want to share. Get shareable link. Copy. Done. And then PNG file. Cool. Okay, now you can access this one too. Okay, you don't have to write down. So, okay, I'm just writing down everything like this. So, in the end, we have a very simple, expression. So, in the end, what it looks like is that we calculate. In the end, what it looks like, we calculate. We basically our idea we replicate future cash flow with the short-term and long-term bond and calculate bond price. But in the end, what it looks like is that we are calculating expected value, some sort of expected value. So P is the case. Let's say P is the probability of interest going down, okay, P is the probability of interest in going down. If we regard P as the probability of interest in going down, then it is like some sort of expected value of cash flow from dividend with this probability, and we get expectation and discount it. So it looks like MPV or discounted cash flow approach in the end, right? But then we have to be careful about interpreting this probability. This is from just mathematical. We derived these probabilities from some very simple linear algebra, actually systems of equation, and this probability is entirely determined by return from short-term bond and return from long-term bond. R is return from short-term bond, and then RU, RD is return from long-term bonds. Okay, it depends on whether interest is going up or down, right? So it shouldn't be actual probability of interest in going up, interest in going down. When, for example, when central bank determine interest rate, they have to take into account like GDP growth and unemployment and FX market and then everything else, right? So the probability of interest in going up or going down should be a function of many of those macroeconomic or microeconomic factors. But in this equation, probability is just determined by that one. So actual probability of interest in going up, going down is actually different from this one. This is pure mathematical derivation. But anyway, this is for some very interesting interpretation because, okay, if we take a look at this one, okay, we calculated expected value of the cash flow and we discount it with risk-free rate, right? This is risk-free. This is short-term rate, right? R is this one, 1.009, right? So this is risk-free rate. So we are basically computing expected value and discounted risk-free rate. In finance, we usually don't discount something with risk-free rate. When we calculate MPV or discounted cash flow in corporate finance, for example, we discount it with risk-adjusted rate, right? Right? In corporate finance, it is WACC, weighted average cost of capital, which is weighted average of cost of debt and cost of equity and some tax adjustment. And cost of debt and cost of equity is risk-free rate plus risk premium, right? But then in this case, there is no such thing. There is no risk premium. We simply calculate expected value and discounted risk-free rate. This kind of calculation is valid only when people are risk neutral. In reality, people are not risk neutral. So we shouldn't do the calculation like this one. But in derivative pricing, actually, this makes sense. Okay. Of course, in the derivative pricing, risk is actually in P. Okay. In our corporate finance class, when we calculate MPV, we calculate expectation in objective probability, right? We don't measure, and we discount the risk-free rate. But in derivative pricing, what we did is we changed the probability distribution for future cash flow and discounted with risk-free rate, right? In the end, what I'm trying to say is that when we do derivative pricing, it is like this situation. We imagine that we are living in like risk-free world, as if we are living in a risk-free world, okay? And then since we are living in risk-free world, in people in risk-free world, they do the valuation like calculate expected value and just discount it everything with the risk-free rate, right? If people are living in risk-free rate, risk-free, risk-neutral world. So this kind of calculation is like assuming that we are in risk-neutral world and doing the valuation. So this kind of approach is called risk-neutral valuation. Okay, this kind of method is called risk-neutral value. Means that in order to calculate the derivative pricing, first we assume we are living in risk-neutral world, and then calculate in that risk-neutral world, we can calculate risk probabilities and then get the expected value. And since we are living in risk-neutral world and we discount it with risk-free rate, then it becomes derivative price. So that kind of risk neutral valuation is identical to like a pizza making approach, which is called replicating portfolio approach. Actually, I'm run out of the time, and this is very important part. So I will explain the relationship between risk neutral approach and replicating portfolio approach in detail next class. This is a very important part. Thank you.